We all know that in reality, our structure has damping, no? Because if you don't have damping, infinite yung vibration niya. Yan. So, madadagdagan yung equation natin ng C because of the damping. So, our equation of motion now is mu double dot plus cu dot plus ku equals 0 because free vibration. Okay, no applied external force. Okay. Now again, our u is ae raised to st. No, our solution is assumed as that. Okay. Then, as we did earlier, no, if you get the first derivative, you have this ase raised to st u double dot. Second derivative is as squared e raised to st. Plug in mo yan doon sa equation. So, and then get the common factor, which is ae raised to st. So, this one will turn out to be this one, ms squared plus cs plus k times ae raised to st equals 0. And then again, ae raised to st is not 0, no, because that is your solution. Therefore, ms squared plus cs plus k is 0, no, to make this equation true, no, as 0. Then, what do you notice? This equation is basically a quadratic equation, no? So a quadratic equation has a quadratic formula as a solution, di ba? Negative b plus or minus square root of, remember, if you have ax squared plus bx plus c equals 0, yan, quadratic equation yan, no? Our solution for that is x is equal to negative b plus or minus b squared minus 4ac all over 2a. Yan. Yan. So, our x here is s, no? So, applying the same concept, no? Your b is this one, okay? Okay, so b, sige. Our b is equal to c. Our a is equal to m. Then our c here is k. So negative b over 2a. So negative b over 2a is equal to negative c over 2m. Okay? So that's that. B squared is c squared. Ito yun, no? 4ac. So 4a is m, c is k. Right? So this is negative b over 2a. This is 2a. Okay? So that is similar to this. Okay? Now, we'll just factor out this inside, no? So negative c over 2m plus or minus, and then pinasok natin yung 1 over 2m dun sa square root. So you will come up with c over 2m square minus k over m. Okay, so if you simplify this and then you insert 1 over 2m dun sa square root sign, you will come up with this. Okay? But remember, omega is equal to square root of k over m, right? So omega square is equal to k over m, which is this. Okay? So mako-convert na naman itong equation na to into this. Yan. So negative c over 2m plus or minus square root of c over 2m squared minus omega squared. Now, since this is a quadratic formula, we all know that in quadratic equation or quadratic formula, you have, may tatlo kang scenario, no? You have 2 real roots, 1 real root, or 2 complex roots. Yan. If b squared minus 4ac here, ito yun, nasa loob ng square root sign, no? If this is c over 2m squared minus omega squared is greater than 0, you have 2 real roots. No? This is all equal to 0, you only have one real root kasi mawawala yung plus or minus, di ba? So, ito na lang yung matitira, yung c over 2m. Kasi kung 0 yan, itong nasa loob. Okay? If this is less than 0, so magiging negative, no? Kasi nga less than, if this is less than 0, you will have two complex roots. So those are the scenarios. Okay. So you just have to review yung quadratic formula and quadratic solution. Now, let's introduce the damping ratio, which all structure has, no? By the way, no, for a typical structure, the damping ratio is about 0.05. Yan, no? Kaya pag nag-i-staad kayo or ETABS, you normally will see a damping ratio of 0.05. Yan. So, ibig sabihin, again, because of the damping, hindi nagiging infinite yung vibration ng structure, no? It dampens out the vibration. Now, so the equation of damping ratio is C over 2m omega. Okay? Now, i-transpose natin to, no, yung omega. So, C over 2m will be equal to C omega. No? Yeah. Then, let's introduce our critical damping, no? Which is 2m omega. Bakit siya critical damping? Because if where's that? If CCR is 2m omega, let's assume C is here. Yan. No? So if this is CCR, no, critical damping, 2m omega, what will be the answer? What will be your zeta, no? Okay? So our C, Greek C, Greek C is equal to damping C over 2m omega. Yeah. So that is why it's called critical damping, because your C will be equal to 1. You know, if your damping all over CCR if CCR is 2m omega, okay? So your C will be equal to 1. Okay, so since inintroduce natin yung formula na C is equal to C over 2m omega, which is the damping ratio, which has a physical application naman talaga, no, on a typical structure, we can now rewrite our S, right? We can now rewrite our S. From this one, we can now rewrite this as this. Yan, no? Because C over 2m is C omega. So this is now C omega plus or minus, and then this whole one can now be rewritten as omega square root of C square minus 1. Okay? Okay. Can show you later, no, how you can, but this is just an algebraic solution, no, walang hidden dito. You can just substitute, plug into mga to here, you can come up with this, no. More on algebraic solution lang yan. Now, this gets exciting, no? Because you can now find the physical meaning of this equation. Okay, so if your C is greater than 1, okay, which is the damping ratio, which has a physical meaning, no? If your C is greater than 1, you have two real roots, no? Therefore, your damping is greater than the critical damping, okay? And we call that overdamp. Right? So we call that situation overdamp. So, masyadong malaki yung damping nung structure or nung object. No? Now, if C is equal to 1, no, we have 1 real roots, as we see here. No, 1 real roots. Your C is equal to the critical damping ratio or critical damping. We call that, of course, critically damped. Now, okay? But if your C is less than 1, no, you have two complex roots, your C is less than CCR, we call that underdamped. Yan. For me, the perfect example of overdump is, uh, alam niyo yung pinto, no? You have a door, no? Na yung swing door, no? The swing door, no? Now, once you open it, hindi kagad siya magsasara. No? For me, that's a perfect example of overdump. No? Whereas the underdump, no? This is most structure. Sabihin natin, typical structure pala. Typical structure, no? Or building is underdump. Yan. Okay? Our typical structure is underdump. This is the situation, no, of a realistic structure. So therefore, your damping ratio is less than 1, no, which is, sabi ko nga, typical damping is 0.05, that is less than 1, right? And you have two complex roots sa equation. Yeah. So I will explore the underdump situation. Okay? So the underdump situation, C is less than 1. You have two complex roots. No? If you solve this, no, plus minus, no, alisin ko yung plus minus, no, i-specify ko, no, explicitly, pakita ko, no, negative C omega plus I omega square root of 1 minus C squared. Because C is less than 1. No? So this is your equation now. Your S1, S2. Okay, so this is for typical structure because our structure is typically underdamped. Okay. Next, so same solution, no, that we have earlier, no, AE raised to ST, right? So our general solution, U is equal to A1 ES1T plus A2 ES2T. So if you notice, medyo iba, but I can show you a snippet of this. No, I got this from a reference from NPTEL. No, if you remember, no, the solution earlier for undamped free vibration is, diba, C1 cosine omega t plus C2 sine omega t. But it turns out this, no, cosine x, no, sabihin natin, let's call cosine omega is equal to this and sine omega is equal to this. That means this formulation is true. No? I can rewrite the general solution as this. Okay? Because we have this identity, no, wherein cosine and sine is what do you call this, is equated by exponent, no? Okay, so let's go back to our solution. Yeah, so this one, okay, so plug in natin yung value ng S1 and S2. Remember, our S1 and S2 is this. So S1 is negative C omega plus, this is plus, no? Plus I omega square root of 1 minus C squared plus A2E S2 is negative C omega minus I omega square root of 1 minus C squared. Okay. Now, let's introduce again another formula. And we call this the damping frequency. Now, earlier, you only knew this frequency. Frequency. Now, this one is the damp frequency because we've introduced a damping. So, therefore, your structure has now what we call a damp frequency. Okay? Because your frequency is only a function of mass and stiffness, right? But now your damp frequency is now a function of the frequency, original frequency, plus the damping ratio. Okay? So this is it. Now we can simplify further our equation here to this because we've introduced the damp frequency. So negative C omega plus I omega d t plus A2E, negative C omega here, yan, the same, minus I omega d t. Okay, remember, meron pa rin tayong t, no, sa ating equation. No? Okay, then, extract natin yung common factor, which is E negative C omega t. Okay, negative C omega t. Yan. So, this is the common factor. And then, A1E I omega dt. S1 is negative C omega plus I omega d. So, this should have this. Para di kayo malito. Yan. Okay? Then, in-extract ko yung negative C omega t. Kasi, yan, by distribution, no? Yung t will be distributed dun sa dalawang term. Yan, no? So, negative C omega t. Okay? So, what's left is A1E I omega dt plus A2E negative I omega dt. Okay? And again, this can be substituted by identity, no? By what I've shown here. So, by using the identity formula, this one is equivalent to C1 sine omega dt plus C2 cosine omega dt. Yeah. Okay? So, U of t. Alright. Take note, no? Meron kang imaginary number, no? I. So, tama. Okay. So, hindi pa tapos, no? Because we still have C1 and C2, no? The unknown parameters, no? So, at time is equal to 0, no? At time is equal to 0, your U naught is equal to, so just plug in the time is equal to 0. So, sine omega d times 0, basically that is 0 because sine 0 is 0. So, okay. Plus C2 cosine t is equal to 0, no? So, cosine 0 is simply 1. Okay, so U naught is equal to 1 times C1 times 0 plus C2 times 1. But this is 0, so U naught is equal to C2. So, we now know C2 is equal to U naught. Next, let's find the first derivative of this, no? So, if you get the first derivative of this whole equation, you got this, negative C omega E, ayan, negative C omega t, C1 sine omega dt plus C2 cosine omega dt. So, nadagdagan tayo ng term because this is this is product formula, no? Because this should be multiplied sa sign, no? So remember, UV is equal to UV prime plus VU prime, no? Sa differential calculus, no? Kaya naging dalawa yung term natin. So, okay? Then plug in time is again plug in t equals 0, no? Sa initial condition. T equals 0, so we have negative C omega. If this is 0, e raised to 0 is simply 1, di ba? e raised to 0 is equal to 1. Okay? So this is 1. Then C1 sine 0, so 0 na natin to. C2 cosine 0, this is 1. Plus e raised to 0 again, that is 1. Times C1 omega d cosine 0 is 1. Minus C2 omega d sine 0 is 0. Okay? So simplify further, u dot or first derivative is equal to negative c omega c2 because this is 0. Ito lang yung may value plus 1 c1 omega d. This one. Okay, further simplify, negative c omega, because c2 is u naught, right? Negative c omega u naught plus c1 omega d. So we can now transform this equation to get C1, wherein C1 is now equal to C omega U naught plus U dot all over omega D. Then, applying the fraction, no? Expand this equation. So C1 is equal to U dot over omega D plus C U naught over square root of 1 minus C squared. Bakit nagkaroon ng ganito? Because omega d is, remember, omega times square root of 1 minus c squared. Yan, this one, no? If you plug in that here, okay? So yan, we now know C1 and C2, no? We can now plug this in to our original solution, no? Here. Dito, no? You can now plug in C1 and C2 here, and if you do that, you will come up with this general solution. Yeah. Then, if you do this sa Excel, sa spreadsheet, your graph will now be something like this. Okay? So, as you see, nagdi-decrease yung amplitude ng motion, no, ng displacement. Kasi, meron ka ng damping. Meron ka ng damping ratio, no? Because meron ka ng damping ratio. So, parang exponential na yung decrease ng motion mo. Yan. Because meron ka na kasing damping. Unlike dun sa undamp, di ba? Yung amplitude ng motion mo, no, pag ganyan-ganyan lang, no, infinite, no? Because nag-introduce ka na ng damping, no? Nag-decrease na yung iyong motion. So, exponentially na yung decreasing. Bakit exponentially? Remember, yung equation mo may e. No? Meron ka ng exponent. Okay? So, that is your damp free vibration. Okay?